Welcome once more, matriculants, and we are moving to the next section of differential calculus. In this lesson, we'll be looking at what we call rules of differentiation. As I already mentioned in the previous videos, these rules of differentiation is just going to be a quick way of solving derivatives problems. As you remember in the previous video, we're talking about rules of first principle. In this lesson, we'll see if we can use certain rules to ensure us that we get the same answer as the ones that we got when using first principle. Basically, these rules are the easy method that are being used for differential calculus. As you saw under first principle, we're basically dealing with the basics, the long method. So in this case, we're just going to be quick and get the answer directly by applying the rules of differentiation. Okay. Now, before I start talking about the rules, we have 5 rules. Okay. But before I start showing you the rules and how we apply those rules, there are certain things that we need to take into consideration, and that is what we call notation. You remember in the first video I spoke about functional notation, which is a very important aspect that is used in calculus. Here also we'll see that we've got different notations that are being used. Okay, a quick reminder: differentiation has to do with derivatives. Okay, derivatives, and as the gradient. As I defined it, I said it's the gradient function of a tangent line to a curve at a certain point. Okay, now when coming to these rules of differentiation, or as I already said, the most important thing that we must take into consideration here is notation. You will realize that we use different notations such as f prime x, which I believe you saw when I was dealing with a first principle, which is the most commonly used one. You have dy, dx, we also have dx. These are the 3 most common notation that we're going to use. Sometimes you'll find that there's also y prime and dy dx. They are mostly used when our subject of the formula is y. Now if you look at this dy dx, you will realize that the gradient is the change in y over change in x. So basically this d means change. So change in y over change in x. So we are differentiating y in terms of x. We will see that when I start introducing the rules. Okay, but all of these things here, they represent one thing, and that thing is derivatives, which means they talk about gradient. The reason why we have different notation is that it is said that during the discovery of calculus, there were 2 scientists who were working on this principle of calculus. One being Newton, the other one is the guy or a scientist by the name of Leibniz. I'm not sure if I pronounce his name correctly. Yeah, but then these 2 guys were working separately. It's like one was busy with his own theory, and the other one was also busy with their own theory. So it seems like they didn't see eye to eye. So that's why we have different notations that are being used, because the other one will come with his own notation and the other one will come with their own notation as well. So that's why now we have different notation. But like I said, they mean and represent the same thing. They all talk about the derivative. Okay. Now let's start with the first rule. So I will say rule number 1. Rule 1. Okay. As I already said, we've got different notations. So let me write them here so that I don't forget. We've got f prime x, we've got dy, dx. So I will show you all the rules using so that you can start getting to see how we differentiate using different notation. They are not that different. It's just that the way we are using them, they are slightly different, but the answer that we get is still the same. Okay, so rule number 1, it says if you are given, if f of x is equals to k and k is an element of real numbers, then the derivative of x is going to be 0. Now what does this mean? This simply means that if I have I'm given an equation that says f of x, sorry, this is not supposed to be f prime, this is supposed to be f, just only f, because it's not yet the derivative. If a function is k can be any number. It can be 10, can be 5, can be 0, can be 100, can be -2, can be -5. As long as it's an element of real numbers. Can also be a fraction. Now, the derivative that we're going to get is 0. And we can see this when we draw a graph of this. So, for example, we are given the graph there. Okay, we know that this is the origin, this is your x values, this is your y axis, and k, let's say k is 5. So it means this line goes, the equation of this line is y is equals to 5. It's 5 throughout. Now if you check this, its gradient is basically 0 because this line is just passing through one point, which is 5, and it's a straight line. So the gradient of this is equals to 0. That's why the gradient, remember this f prime x is the gradient of a constant. This is a constant. The gradient of a constant is equals to 0. Okay? With a different notation. So if we are given y is equals to k, this is still the same. K is an element of real numbers. Then the derivative is going to be x, and the answer that we are going to get is 0. Similarly, if we use this notation, if d is into k, then the derivative is going to be 0. We realize that with the first one, the first notation, the function is f of x, the derivative is f prime x. Here the function is y, the derivative is dy dx. But here, when we are differentiating, we just write equals to and get the answer. So we don't have the notation for this. We just make sure that we write an equal sign and then we get an answer. Let's look at an example. So we've got the example. So let's say we are given to determine the derivative of f of x is equals to 10. So we can see that this is a constant. It doesn't have variables attached to it. So the derivative of a constant, we know that the answer that we're going to get is going to be f prime x is equals to 0. If it was asked in a different notation, which was y is equals to 10, then the derivative was going to be dy dx is equals to 0. Also, if it was given in a third notation, dx of 10, then the answer that we're going to get, we just say equals to 0. I hope you are starting to get the picture. Okay, let's move to the second rule. So rule number 2, Rule 2. It says if f of x, and you will see because we normally use f of x. This f of x can be g of x, can be h of x, but for the sake of this lesson, we'll just stick to f of x so that you get and understand the rules before we start complicating things and introducing different notation. So if f of x is equals to x to the power n, okay, then the derivative will be f prime x. Now look at what's going to happen here. We take the n, which was the exponent, we drop it down, then we remain with x to the power n, then we take the very same n, we subtract 1 from it, okay? And then if we are given a different notation where they say y is equals to x to the power n, we do the same thing, it's just that the notation here is different. The answer, the derivative is going to be dy dx, but the answer is going to remain the same, nx, n minus 1, okay? And also with the third notation, which is different to the other two, it's going to be dx of x to the power n, and the answer that you're going to get, we're just going to say equals to n times x, n to the exponent minus 1, n minus 1. Okay, I hope you are starting to get a clear picture of what these rules, or how these rules are being used. So let's look at an example. So example, let's say we are given f of x is equals to x cubed. Then the derivative will be f prime x is equals to what happened here. So I take my n in this case is 3, I drop it down, then I had x, then I take the very same 3, I subtract 1, which was 3x squared. Let's see with the second notation. The second notation says if I'm given y is equals to x cubed, what do? I write the notation for dy dx, dy dx, but the answer is going to remain the same. This will be 3x, 3 minus 1, which is equals to 3x squared. Is going to be d of x into x cubed. The answer that I'm going to get directly is going to be 3 minus 1, which is 3x squared. So now we see that with the first two notations, what you do is if we have f of x, the notation there is f prime x. If you've got y there, the notation is dy dx. But if you have dx, you just write equals to and then the answer. Let's move to the third rule. So rule number 3, it says, you'll see it's a combination of rule number 1, rule number 2. So it says if f of x is equals to k x to the power n minus 1. No, sorry. To the exponent n. Then the derivative will be f is equals to k times n minus 1. So you will realize that here, this is the first rule, the second rule. So you take your n you drop it and you subtract 1. And then this k here, instead of being a constant from rule 1, in this case it's a coefficient. Okay, now if it was given in a different notation, it was going to be y is equals to k times x n. Then the derivative will be dy dx to k n times x to the exponent n minus 1. Also, this was going to be d of x into k x n. It was going to be k times n times x n minus 1. Okay, let's have a look at an example. So we've got the example. We've got f of x is equals to 4x squared. Okay, so what will be the derivative? The derivative will be f prime x is equals to, I've got my k, in this case my k is 4. Then I take my 2, which is n, I drop it, it becomes 2. Then I say, then the very same 2 I subtract 1. And then when I simplify this, I'm going to get 4 times 2, 4 times 2, it's 8x to the exponent. Similarly, with a different notation, y is equals to 4x squared. Then the only thing that is going to change is the notation, dy dx, which is going to be 4 times 2 times x, 2 minus 1, the answer is 8x to the exponent 1. Last but not least, with the dx notation, dx of 4x squared, the answer that you're going to get is going to be 4 times 2 times x, 2 minus 1, the same answer, 8x. Okay, now let's look at another example. This will be example 1, this will be example 2, but here I will only use one notation. So if we're given f of x is equals to half x cubed, we are going to apply the same principle and say f prime x is equals to, I've got my half there, I drop the n, it's going to be 3, then I take the x and then the cube there and I subtract. Half times 3 is going to be 3x squared, and that will complete this question. If it dy dx, and if it was this dx notation, I was just going to have equals to, then the answer. Okay, next rule. Rule number 4. Now I will combine rule number 4 and 5. So rule 4 and 5. So this will be the last rule that we look at. Okay. Now this is going to be a bit complicated, but you will see when we look at an example that it's actually easy. It's just that it's a bit difficult to show this in the form of general notation, but I will try. So let's say we are given f of x plus or minus g of x. Now the derivative will be, you take the derivative of the first one, you add or you subtract based on the operation there. If it's a positive, you put a positive. If it's a negative, you put a negative. Then you take the derivative of the second one. Okay? Similarly, if you've got, let me see how I can represent this. This one is going to be a bit difficult to represent. Let me move to the third notation. You say when you have dx into, and now you've got f of x plus or minus g of x, then the derivative is just going to be equals to, it's going to be, you differentiate your f of x first, then you differentiate your g of x after, and then this will complete your solution. Let's look at an example. Hopefully it will make sense now. Let's say we are given so you've got the example. We are given f of x is equals to 4x minus x cubed. Okay, and according to the first notation, it's going to be f prime of x is going to be, what is the derivative of 4x? The derivative of 4x, remember rule number 2, it says you leave your 4 as a constant, as a coefficient as it is, then you've got an x. Remember here we've got 1, so you drop the 1, so 1 is 4. So even if I don't write the 1, but we know that it's there, then from the very same exponent, which is 1, you subtract 1. Okay, that's the first part. And then minus, this is this minus, and it says this one, this is first, this is the second rule. It says now you drop the exponent 3, and then from the same exponent you subtract 1. So the answer is going to be 4x to the exponent 0 minus 3x squared, and we know that any number to raise to the exponent of 0, it's 1, so this will be 4 minus 3x squared. If it was a different notation, this, if I was giving it as y is equals to 4x minus x cubed, it's going to be the same thing. The derivative is going to be dy dx, which is equals to, you will do all of these steps until you get to an answer of 4 minus 3x squared. But if it was the other notation, it was going to be 4x minus x cubed, then the answer you just write equals to, and then you do all those steps until you get to an answer of 4 minus 3x squared. I'm not going to repeat the steps because I've already shown you the steps here. Okay, now that I'm done covering the rules, I will show you I will do 7 problems, and from those 7 problems there are important things that I need to mention, because the rules that I was showing you, the examples that I was doing when showing you these rules, those are the easy problems. It's unlikely that you're going to get those problems. So I took 7 problems from previous exam papers, and then from those 7 problems, when I do them, I will give you the tips on how to use these rules of differentiation, because you don't just get a question and then just apply the rules. There are certain things that you need to do first before you can start applying your rules of differentiation. Okay, so the problems are as follows, and as I already said, I will give you a couple of tips, and here it's where I'm going to do my problems. Okay, so looking at the tips first, or let's look at the question. It says determine the derivatives using the rules of differentiation. Okay, now, okay, I'm going to do the first one. It says f of x is equals to x minus 2 the square root of x. Now let's look at these tips quickly because they are very important. As you can see, these problems is a bit complicated. It's not not one of those easy ones that I did when I was showing you the rules, when I was doing examples. It says, before applying rules, simplify fully and ensure that there are no roots, no brackets, and no fractions. So before we can start applying the rules, we must make sure that we get rid of all of those things. And we can see here that we've got a root there, we've got fractions, so we must make sure that we simplify first by getting rid of those limiting factors before we can start applying the rules. So when I simplify, I continue with my notation, so it's going to be x minus 2 all divided by. Now if you look at the square root of x, now there's a set rule that says if you've got x, a, and b there, then the answer that you're going to get is going to be x to the exponent b over a. So I'm going to apply this rule here to get rid of the square root, which is the first thing that I need to get rid. So this will be the same as x to the exponent 1 over 2. Now we can also recall that if you've got a over b plus c over b, this a plus c divided by b, because they have the same base, the same denominator, and say, okay, this is the same as x divided by x 1 over 2 minus 2 over x 1 over 2. Okay, now when dividing parts of the same base, we separate the exponent. So this is the same as 1. So if I simplify this, x and then 1 minus half, I'm going to get 1. If you subtract half, you will get half. Okay, 1 over 2 minus. Now I don't have brackets, so I will move to the first one. It says you must remove fractions. Now I don't want my variable that I'm going to derive to be in the denominator. That's why I need to get rid of the fractions. So this will be true. Now the question is there a way in which I can write this without using the division sign? And the answer is I can write this as x, then I take the exponent, which is half, then I change the sign and make it 1 over 2. Remember, if you've got x is the same as 1 over x. So I had this, now I change it to that. Now that I don't have brackets, I don't have fractions, I can start applying my rules of differentiation. Since I don't have space there, I'll just write it here. So now I'm applying rules of differentiation, and I check the notation for this will be f prime x will be 1 over 2 times x. Remember, I drop my exponent, then the same exponent I subtract, okay, then minus 2 there. I do what? I drop my exponent together with its sign, the negative 1 exponent, I subtract 1. And if I simplify this, I will get 1 over 2x. What is half minus 1? It's going to be negative 1 over 2 minus negative times negative, it's positive. 2 times half, it's 1. So I'll be left with x. Negative half minus 1 is going to be negative 3 over 2. But it is also advisable to leave, or sometimes the question will ask you to leave your answer in with a positive exponent. You can see here we've got negative and negative, so we must change this back to 1 over 2x. Now you see the x was multiplying the 1, but now I took it down using this principle. So the x here will have an exponent of positive 1 over 2. Plus, also here, this is the same as 1 over x to the exponent 3 over the end. B. We've got d of x. We've got x to the exponent 4 divided by 2x minus 3 divided by x plus 5. Okay, you will see here that we've got 2 or 3 rules combined in one problem. That's why I said the ones that you're going to get are going to be a bit more complicated. But like I said, follow the rules, follow the tips. Make sure that you don't have roots, you don't have brackets, you don't have fractions. Okay, and remember this notation. When you start applying your rules of differentiation, you just write equals to. But now that I will be simplifying first, I will continue writing my notation, which says d of x, because I need to simplify whatever that is inside the bracket. Okay, when I look at this is the same as 1. It is advisable to also, you can add as one of your tips. It is also advisable to make sure that you separate the numbers with the exponent. So instead of writing x to the exponent 4 divided by 2x, I can write it as 1 divided by 2 multiplied by x. Okay, but I also know that if I have x to the exponent 4 divided by x, dividing powers of the same base, you separate the exponent. So this will be the same as x cubed, because 4 minus 1 is 3. Okay, minus 3 so it's 3 there. Now I need to take this x up because I want to get rid of the fraction. So as you saw in the previous problem, this is the same as x to the exponent minus 1. Okay, and then 1 over 5 is 1 over 5, even though it's a fraction, but it's just a constant, so that one we can leave. Now that I managed to get rid of roots, brackets and fractions, I will start applying my rules of differentiation. And for this, we know that there's no notation, so I just say equals to, then I say 1 over 2, then I drop my exponent there, which is 3 multiplied by x, then I take 3, I subtract 1. Okay, minus, I have my coefficient there, it's 3, I dropped my exponent there as minus 1, then I subtract 1 from my exponent, minus 1, minus 1. This is a constant, and remember the first rule, the derivative of a constant is 0, so I can say plus 0, or I can just leave it out. And then if I simplify this, I'm going to get 3 divided by 2 x to the exponent squared plus, I say plus because negative times negative is positive, 3x to the exponent minus 2. As I said previously, it is advisable to live in positive with a positive exponent, so therefore this will be 3 divided by 2 x squared plus 3 divided by x squared. C. It says determine dy dx if the square root of y is equals to x minus 2. Okay, so since the notation says dy dx, it means we must differentiate y in terms of x. So we must make y subject of the formula, right? So we must get rid of the square root. So we know that this is going to be y to the exponent 1 over 2 using that rule for sets, which is equals to x minus 2. Now I can't apply the square root on both sides, but I need to make this y to the exponent 1. Okay, so what I'm going to do is I'm going to multiply the exponent with 2 divided by 1. Why? Because I want this 1 to cancel this 1 and 2 to cancel this 2, so that I'm left with 2. But remember what I do on the left, I also do on the right. So this is going to be in one bracket to the exponent 2 that I used there. And then this will now be y is equals to x squared. Now I got rid of the roots, I must get rid of the brackets. If I FOIL this, I will get x squared minus 4x plus 2. Now I can, I say, okay, if I apply my rules of differentiation, I check the notation that was asked. They say I must use dy over dx. And the answer that I'm going to get, it says Now you can directly use the rules and you will get 2x, 2 minus 1 is 1, minus 4x to the exponent 0. This is a constant, so the answer is plus 0. And any number raised to the exponent of 0, remember, this is 2 minus 1. So this will be 2x minus 4, because any number raised to the exponent of 0 is 1. Moving to D. D, it says, what is, if we are given g of x is equals to minus 2 over x, determine the derivative. If you watched the previous video when I was covering first principle, you will realize that this problem was given and I had to solve this using first principle. And the answer that I get is the answer that I got is the answer that I'm going to get now using rules of differentiation. Okay, so if I simplify this, I need to take x up there because I don't want fractions. This will be minus 2x, will change the exponent because the exponent is 1. Now the exponent will change to negative 1. Now that I don't have roots, I don't have brackets, I don't have fractions, I can start applying my rules of differentiation. Okay, and the answer that I'm going to get, firstly, the notation is going to be g prime of x. As I said before, it can be f of x, it can be h of x. In this case, it's g prime x. So it's going to be, I've got the negative there, I've got the 2 as my coefficient. I drop my exponent x, then from the same exponent I subtract 1, so 1 minus 1. The answer that I'm going to get, it's negative times negative, it's positive, so it's going to be 2 to the exponent x minus 2. And if I simplify this to right hand, it's going to be 2 divided by x squared. And if you go back to the previous video that I made when you using rules first principle, you will realize that I also got the same answer. Okay, now E, it says y is equals to 2 divided by 3x, so 3 divided by 3 divided by 2x minus x squared over 2 plus w. Great-offs, same process, same procedure. Make sure you simplify. You don't have roots, you don't have brackets, you don't have fractions. So that is what I'm going to do. So I separate the numbers with the variables. So this is going to be 3 over 2. Then my x there was at the bottom, so I'm going to take it up because I don't want fractions. So this will be minus 1. Minus 1 over 2x squared plus w. Now I apply my rules of differentiation. So I go back to my quotient and it says I must use this notation. Okay, so this will be dy dx, which is equals to, remember I leave my coefficient as it is, 3 over 2, my exponent minus 1, then from the same, this I subtract 1, so it's going to be minus 1, then minus 1, minus coefficient, I drop my exponent, I say 2 that I dropped, and then I subtract 1, plus, now look at this w. This w, it's a constant, so I'm not going to entertain it. Why? Because the question says here, the notation given, it says determine dy dx. So I must make sure that I have y as my subunit of the formula, and I only differentiate all the terms that have an x. So everything that does not have an x, I ignore it. I take it as a constant. That is why this w is the same as a constant. It's the same as being 5. It's the same as being negative 25, negative 100. So the derivative of constant, we know that it's 0. Now I simplify this, divide by 2x, and then negative 1 is going to be negative 2, then this will be 2 divided by 2, it's 1. Then this will be x to the exponent 2 minus 1 is 1. Remember, this 2 positive exponent, this will be 3 over 2x to the exponent 2 minus x, and that will complete this quotient. F, it says d of x into 3x squared minus 2x minus 5, close bracket, divide by x plus 1. Okay, remember you have to say fully first by removing roots, by removing brackets, and by removing fractions. We don't have roots here, but we have brackets. Or no, we don't have brackets, we have got fractions, so we must get rid of those fractions. So since that I'm simplifying, I continue writing my notation and I simplify whatever that is inside the bracket. And here at the bottom I have x plus 1. I can't do anything with that. Here you will realize that you can factorize this. So you open two brackets, and then this will be 3x and x there. This x plus 1 will guide you that one of the terms there must be x plus 1. And as you know, the factors of 5 is 1 and 5. So the 5 must go there. And the bigger number, take the sign of the middle term between 5 and 1. Which one is the bigger number? It's 5. So it must take the sign of the middle term. So it will be minus. Okay? And then you will realize that here, this term will cancel that. And then I'm left with dx into 3x minus 5. Now that been simplified, I can apply my rules of differentiation. And remember, with this notation, I just say you can write it equals to there, or you can just write it here, say equals to, without writing the notation. And the derivative of 3x is just going to be, I have the 3 there, remember I have a 1 there, so I drop the 1, and then I have an x, I subtract 1 from that 1. This is a constant, so the derivative of constant, according to rule number 1, it's 0. So this will be 3x 0, which is the same as 3. Okay. Lastly, we look at G. It says determine f prime 1 if f of x is equals to 7x plus 1 all squared. Before we get to the f prime 1, we must find the derivative first, because we will realize that this is a combination of the concept of functional notation, okay, which I covered in the first video of this lesson, or of this topic, differential calculus. But first I must find the derivative. So I'm given that f of x is equals to x plus 1 squared. So I have bracket, so I must get rid of the bracket. So this will be plus 1 and 7x plus 1. If I simplify this, I will get 49x squared plus 14x plus 1. Okay, now everything is in simplified form. I've got no roots, I've got no brackets, and I've got no fractions. I start applying my rules of differentiation. Where's my pen? Okay, I apply my rules of differentiation. The notation that is given is f prime. So I'll say f prime x is equals to, I'm going to have my coefficient there is 49, I drop the 2, I've got then x, I subtract 1 from the 2, plus 14x 1 minus 1, which will give me 49 times 2 will give me 9 times 1, 98 x to the exponent 2 plus 14, this will give me x to the exponent of 0, which is equals to 1. And 14 times 1 is 14. Now I got f prime x. Now the question says I must find, so I have determine f of x, which is the same as 98x squared plus 14. But the question says I must find f prime of 1. Functional notation. So it says where I see x, I must substitute 1. So I will have 9 squared plus 14. This will give me 98 times 1 squared, which is 1, which is times 98 is going to be 98 plus 14. And the final answer that I'm going to get is 1, 1, 2. And that completes this problem. Grade 12s, I hope you learn a lot from this video, from this lesson. This completes our section that we had on rules of differentiation. For you, make sure that you practice, you will realize that the more you practice, the more you'll be able to see the tricks, and then you will be able to solve these problems quickly without writing this. You will see from the beginning that, okay, if I've got 49x squared, the derivative is just going to be 49 times 2, which is going to be 98. So the more you practice grade 12s, the more this is going to be easy for you. And while I'm busy saying that, I realized that there's a mistake somewhere here. I hope you managed to see the mistake. This 2 minus 1 will give me 1. Fortunately, this doesn't have an impact on the final answer. This is 1. This is 1. 1 squared is 1. So it's not going to have an impact on the final answer. Okay, so yes, make sure that you follow the same procedure, the same method, the same principle. And on the next video, I will be doing tutorials of differential calculus, where I will combine your first principle and more. You will get more problems on rules of differentiation. Until we meet again, take a good care of yourself and stay safe. Thank you.